Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Imran bin Muhammad Sopian 18002226, and as for today I would like to present about Bernoulli's theorem for my lab session MEB2043 fluid mechanics. Before we start with the experiment, I would like to introduce to you about definition of the Bernoulli's theorem. So Bernoulli's theorem in fluid dynamics relates among the pressure, velocity and elevation in moving fluid, the compressibility and viscosity of which are negligible and the flow of which is steady or laminar. The first theorem is derived in 1738 by the Swiss mathematician Daniel Bernoulli, and the theorem states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid potential energy. Moving on, I will start with the experiment to make the definition become more clear. So the objective of the experiment is to investigate the validity of Bernoulli equation when it is applied to a steady flow of water through a tapered duct. So this is the list of the apparatus that needed in this experiment. The first apparatus that we need is F1 to 10 hydraulic bench. Second one is stopwatch. The third one is air bleed valve. The fourth one is manometer tube. And then we need unions, gland nut, hypodermic probe, test section, adjustable feet, and water inlet. So this is how all the apparatus will be set. So we can see on the above, we can see air bleed valve, and then we have manometer tube, unions, and then gland nut, hypodermic probe, test section, adjustable feet, and water inlet. So let's go to the methodology of this experiment. This is the step on how to conduct this experiment. The first one is to place the apparatus on the hydraulic bench and ensure that the outflow tube is positioned above the volumetric tank. The second one is to level the apparatus base by adjusting its feet. And the third one is to install the test section with the 14 tapered section converging in the flow direction. The fourth step is connect the apparatus inlet to the bench flow supply, close the bench valve and apparatus flow control valve, and start the pump. The fifth is push air from the pressure tapping point and manometers, and take readings of manometers when the water level in the manometers is steady. Next, we need to measure the total heat by traversing the total pressure probe along the test section, and then measure the flow rate by a time volume collection by closing the ball valve, and use a stopwatch to measure the time it takes to accumulate a known volume of fluid in the tank. Then, reduce the flow rate to give the heat difference of about 50 mm between manometers. And next, we need to repeat the process for one more flow rate with the difference approximately halfway between those obtained for the minimum and maximum flows. Reverse the test section with the 21-degree tapered section to observe the effects of more rapidly converging section. And lastly, perform 3 sets of flow and conduct pressure and flow measurement as above. Alright, so let's move on to results and calculation. So the formula that will be used in this experiment is this equation. So in this equation, P represents as pressure, G represents as acceleration due to gravity, V represents fluids of velocity, and Z represents vertical elevation of the fluid. But in this case, since the position is horizontal, there will be no difference in height, so we can discard Z1 and Z2. Alright, so this is our new equation without Z. Okay, so P, also known as hydrostatic pressure along the flow, is measured by the manometers tapped into the duct. So we can calculate the pressure head, which is H, by using this formula. H equal to pressure over density times gravitational acceleration. So we can simplify, become this one. And then in which V2 square over 2G is called as the velocity head. And then the flow velocity is measured by collecting a volume of the fluid, and the flow rate is calculated as Q equal to Vt. So, and then we can calculate the velocity of flow at any section of the duct with a cross-section area by using this formula, V equal to QA. As we have all the calculation, we can insert all the data into this and make the graph to make conclusion for this experiment. So to conclude our experiment, there will be three conclusions. So the first one is we can say that the Bernoulli's theorem has been proved through the experiment conducted. The second one is the area of pathway and the velocity of the flow are inversely proportional. So we can say that when air flows into the convergent area, the velocity will increase, and when air flows into the divergent area, the velocity will decrease. Last but not least, we can see that Bernoulli's theorem has been applied in few applications such as F-flight, takeoff, and spinning ball curves. So that's all from me. Thank you.